Hello, I'm Neal Gupta from Physics Partners, and in this short film we're going to look at potential difference. The film is part of a series to help you with your physics teaching, especially if you're new to teaching or teaching outside your specialism. Students often use the word current when they mean potential difference and vice versa, so I'll focus on ways to introduce this concept so as to avoid misconceptions, and we will also look at the definition of potential difference. Feel free to pause and take notes or rewind and watch the video again. When first teaching potential difference to students, I use simple models to introduce this idea. Models can be particularly useful in physics as they can turn an abstract idea into something quite concrete and tangible. Let's have a look at our first simple model.
So here is our first model to help us with our understanding of potential difference. Consider a ball on the floor and a ball on the table. The ball on the floor doesn't move on its own. The ball on the table doesn't move on its own, even though the energy in its gravitational store has been increased. How can we make the ball on the table move? We can make the ball on the table move by lifting the table at one end, as shown in the image. Creating a difference in the gravitational store between the two ends makes the ball move. This simple model introduces the idea that creating a difference can make something happen. Let's have a look at our second model. Here is our second model, and this is called the penguin race game. And as you can see, the penguins are being raised by the motorised escalator to the top of the ramp. When they reach the top, they are able to slide down. When the penguins are at the bottom of the ramp, they have less energy in their gravitational store compared to the amount of energy they have in their gravitational store when they are at the top of the ramp. The escalator creates a difference which allows the penguins to slide down the ramp. So in our first two models we could see that a difference allows a change to occur. Let's look at our third model. And here is our third model, and it's called the bowls and beads model. And I've got two bowls here, and I've got a chain of beads 10 meters long in one of the bowls. And if I hold the bowls at the same height, then nothing happens. There's no movement of beads. But if I create a difference in height by raising one of the bowls, we get a movement of the beads. Okay, if I then move the bowls so they are at the same height again, nothing happens. But if I create a difference in height, the beads flow. And the greater the difference, the faster they flow. And here, the greater the difference, the faster they flow. If I have them at the same height with no difference, we get no flow of beads. But with a small difference in height, the beads start to flow. A larger difference in height, they flow even faster. So this is our third model, again showing that when we have a difference, we can cause a change to occur. So we have now seen three models, and how can we relate those to what actually happens in a battery? How does a battery create a potential difference? Well, to explain that, I've set up a homemade battery here. I'm using a lemon and two different metals. I've got a small piece of copper pipe inserted into the lemon and a galvanized zinc nail. So I've got two different metals, copper and zinc, and they are connected to a multimeter which is set to read potential difference. And if I switch the multimeter on, you can see that there is a potential difference of 0.952 volts created by this lemon battery. So how does the battery create a potential difference? The lemon contains citric acid and electrolysis occurs. The copper loses electrons and the zinc gains electrons. So the copper becomes positively charged and the zinc becomes negatively charged. So now there is a difference in charge between the two metals, and we have what is known as a potential difference. The excess electrons in the zinc are attracted to the positive pipe, and this causes a flow of electrons or current through the wires, and the LED lights up as the electrons flow through it. As we have seen with the previous models, a difference causes a change to occur, and the difference in this example is called the potential difference. So how do we define potential difference? Consider a lamp connected to a cell as shown in the image. The potential difference across the lamp is defined as the energy transferred per unit charge to the lamp. This can be described mathematically by the formula potential difference equals energy transferred divided by the charge moved. In symbol form, this is V equals E over Q, where V is the potential difference measured in volts, E is the energy transferred measured in joules, and Q is the charge moved measured in coulombs. But the important thing for your students to understand is that the cell creates a potential difference, and it is this difference that allows a flow of charge or current. I do hope that this film has given your students a deeper understanding of this concept rather than just surface recall. Thank you very much.